I will tell you today something about our new functionality in our products, which allows the customer to have a simple integration of brownfield machines into a standardized OPC UA solution. The agenda for today is some definition of some shortcuts, UNS, UAS, SAS, what is that? Then standardized unified OPC address space, a typical use case, some softing products which are able to realize the scenarios, and then I will say a live demo, and last but not least a short summary. Starting with some, I will say, keywords which are every day in the market. Unified namespace, some others call it unified address space, some other wording are standardized address space with all these shortcuts. I will say, personally, for me, it was very hard to understand the differences between all these wordings. That's why I take the chance to say some small words about the different topics. Maybe it helps you also to understand it. A unified namespace is a central, organized, and structured repository. What does it mean? On a central place, they are all data available. They are all aggregated and they were made accessible for all the applications from an industrial environment, which has in this case a single point on which they can connect to all devices, system, and applications. This is the definition of an UNS. Then we have the second topic, unified address space. A unified address space is a consistent way to address and access data across a complete system. It is mostly used in industrial protocols where more or less the elements are using a common addressing scheme. And then I will say a standardized address space is similar like a unified, but in this case the address space refers to a structured way to organize and reference the data within an addressable system. It is also generated in the topic in the area of industrial standards. This helps to have an easy interoperability and consistency across different vendors and applications. I personally like all three topics, and I personally will show you later on how you can combine everything together. But coming now to a second overview about this topic, what are the different features and what are the purposes and the scopes? First of all, the purpose of a unified namespace, organize all enterprise data in a single namespace. Compared with a unified address space, it provides a single addressing model for accessing the data. So the one is organizing and providing the data, and the other one is possibility to addressing the data. And the last one, the standardized address space, it's an, I will say, industry-wide standard for the structure of the addresses. And the scope for all this is, from my today's webinar point of view, is to help the customer to bring the data from the OT into the IT systems. Unified namespace, mostly used enterprise IT, OT, IT. Unified address space is a little bit system specific, for example, for OPC UA, and the industry, the standardized address spaces are for industries and application-wide scopes. From the standardization point of view, as you can see here, unified namespace is often based on MQTT or OPC UA. And the unified address space can have basis on different protocols. My example today is OPC UA and follows industry standards like PACML, which is a companion standard of the OPC UA foundation. It shows also everything is related to UA in this case. When we take a short look to example use cases, unified namespace means IoT data aggregation to make it visibility. The UAS is OPC organized addressable objects to address it. One is visibility, this is addressing. And the last, the standardized, is more or less to have a consistent tech naming across the complete automation system. So every, for example, sensor from different vendor are looking from an application point of view the same. So this is a standardized way. And I personally like really to combine everything. I have already mentioned a little bit this topic, companion specifications. This is one of the most important topic from my personal side within the UA world to realize, I will say, an easy way for application to get access to the data. Why? Because this companion specifications defines a standardized information model for maybe a domain, device type, or industry. With some examples, for example, the PADIM is for process automation, Weihenstephan is for food and beverage, PACML is for packaging machines. There exists, I will say, a lot of more, roughly more than 100 companion specifications are currently listed on the OPC Foundation webpage. But in addition, also bigger companies can also create their own companion specifications. What is the purpose of this companion specifications? My favorite is here the standardization. Why? It defines really a common data model, the structure and the semantic for the specific industries. So as explained, a sensor looks independent of the vendor, looks from an application point of view every time the same. And all information which are needed for the sensor are provided via the standardized OPC companion specification to the application. It ensures that these devices have an interoperability, and also it makes it easy to get access to different manufacturers so they can easily communicate to each other. And also the integration, it's, I will say, the key point at the end, allows an easy integration into applications like MES, manufacturing execution systems, ERP systems, or in any kind of industrial Internet of Things platforms. Why? Because with these companion specifications, when an address space looks like a companion specification, it provides all the needed data for the application. This is for me the most important topic, that from the upper layer, it will everything provided, that there is no mapping and nothing else on the application level needed. Coming to my favorite is to combine everything, what I already mentioned at the beginning, to have at the end a standardized and unified OPC address space. I will combine in this case the structured data model from this companion standards. I will say from the UNS, Unified Namespace, the single source, because we will also aggregate everything into a single address space. So it helps really the customer to have an easy communication between the devices, application, enterprise systems, and it ensures really that everything is interoperability and has also efficiency. The key benefits from a customer point of view is the data are unified, their interoperability, the data are consistent, standardized. Exchange across all system components are really easy. The data quality and also the contextualization, it's important because it provides additional information, insights on this data, which helps finally the application. And the integration effort and the costs are reduced because only on one step, on the lowest level, normally the data will be provided in the standardized unified way, and on the upper levels, there is no need for any mapping or for additional effort because everything will be provided out of the standardized and unified OPC address space. This is my, I will say, point of view of this topic. How it looks like a little bit from an brownfield, I will say, field application. We have here, just one second. We have here on the lowest level, for example, some PLCs or UA server maybe already. We have also maybe CNC machines, and all these devices provide data. And all these devices have a different structured way to provide this data. PLCs, for example, in Siemens PLCs, I will show it later also in the live demo, provides the data within DB data block. UA server maybe provides it already a little bit structured, but every, I will say, engineer who develops such kind of application, servers, or PLC, has its own look and feel about its structure. And this will be normally aggregated, in our case from our products, into a local address space. Our products are a little bit more flexible than some other products. We have not only the possibility to aggregate it to one address space, we can also aggregate the data to multiple address spaces, which allows us more feature sets on the upper layers. So we can aggregate the data, what we get out of this devices, sources, to an aggregated address space, in this case, one. On top of this, we have now the possibility in our system to model and map the data based on a companion specification. For example, PADIM, process automation, Weihenstephan, or whatever it exists. And this underlying address space will be then, after the modeling, mapped to this newly created address space. And then we provide to the UA application, first of all, a single point. It is possible to have it a single point. In some cases, it's needed to have multiple points, but we can provide it with a single point. So we have the unified namespace functionality provided as a single point. We provide it via an address space with the OPC UA vault, and last but not least, via a standardized address space, because we are able to load this companion specifications, model out of it an address space, and then map the data from the underlying servers. So this is my approach to have the best integration of brownfield devices into a modern, I will say, UA world. Aggregate everything, map this to a standard, independent if it's in this case PADIM or it's an own defined standard. Maybe bigger companies have their own defined standard, and then provide it via a standardized address space to the clients. So what are the features at all? Here are a little bit the marketing topics. We represent the data via OPC UA using a companion specific based address space, for example, like PADIM or Weihenstephan for food and beverage. We are able to aggregate the data of PLCs, CNCs, or underlying UA servers address spaces into a virtual address space. And this enables us to streamline across the complete industrial automation systems. We have the capability in our product now to modeling or load address spaces according to UA companion specifications or self-created address spaces. And then this is our main new feature, what we provide with our last release, is we have also a flexible mapping of the variables of the underlying devices, controllers, or UA servers to the standardized and unified address space. And this helps you as a customer or as a system integrator to provide for your, I will say, applications and standardized address space. Which are the software products which are supporting this functionality right now? First of all, we have a secure integration server, which is a Windows-based application, which provides an OPC UA client and server interface, in addition also MQTT, which aggregates the underlying UA servers. In the future, it will be also enhanced with some PLC protocols. This is our Windows solution. We have on top also edge connectors. These are Docker-based solutions, which connect, for example, to Siemens, Allen Bradley, Modbus, Fanuc, CNC machine, or Siemens Numeric 840D controllers and UA servers, and also be able to provide this data via UA or MQTT. And then we have the same also with our EdgeGate as a hardware appliance, which is also able to get the data from Allen Bradley or Siemens PLCs and providing also this data via OPC UA and MQTT. So these are the software products which are currently supporting this standardized and unified address space functionality. Coming now a little bit in the direction of a live demo, I think it's also for you very helpful to see how it works in the practice. What I will show you today is to read the process data from a Siemens or from two Siemens controllers via an Ethernet interface and provide this data via an OPC UA server in a PADIM-based address space. For this, I have two underlying S7-1500 PLCs. It can be also an S7-300, or as shown, can be a Modbus device or an Allen Bradley device. For the demo, I use the Siemens devices. get with our edge connector Siemens the data from this and provide this data via UA to an OPC UA client application. This is the configuration interface of one of our Docker-based solutions. It is the edge connector Siemens with the newest software version, which is 2025.02, which is already available via Docker Hub. On this, we have the possibility to connect to MQTT brokers. We have an OPC server interface. I will show it later a little bit more in detail. And we have the possibility to connect to different controllers. For example, to Siemens S7 1200-1500. I have already prepared one connection, like in a cooking studio, I have something prepared, but I will add here a second connection. When I press add, there's a simple, I will say, interface on which you can add some devices. I will add here an S7 1500. This is my second S7 1500. I must provide an address, but it's not one which is already here in the field. Just 1 second. This is my IP address, and here I can decide in which address space I want to aggregate it. I like to have only one at the moment. For the short case, it makes it easier, which is all connection address space. In addition, we have also the possibility with some advanced settings if something would be changed regarding timeout or TLS topics, but normally there is no change needed. If I press here save, we should have automatically a connection to this S7 1500. That's all what you have to do with an S7 1500. Why? Because all the structure of the data, the address space, we are reading out of this VLC via browse functionality, which allows to browse an S7 1200-1500. This is, I will say, the basis, the connection. Coming now to our address spaces. If you want, you can here show the current all connection address space, how it is aggregated between these two controllers. It's only the possibility to take a look if everything works fine. We can see here also the complete data block structure. But coming now to our new functionality, local and mapped address spaces. On the first topic, we have the possibility here to upload companion standards. I will upload some companion standards, for example, TI. I will choose the file, select the TI address space. It's one of the most used, I will say, companion standards. Is for data integration solution. It's something like a base companion standard. I will upload a little bit more, only to show you that it's quite simple and quite easy to upload something. I will have here some machinery as well. Upload it, save it. We show also the version, and if everything works fine, we have here also the green check mark. Or I can also upload, for example, the Weihenstephan for food and beverage. Here. Okay, save. Oh, here we have a problem. Minimum one required node set is not uploaded. Okay, we can see we need something in addition. I know for Weihenstephan, the PADIM is also needed. Sorry. I will choose the PADIM. When I save, oh, and now you can see the Weihenstephan is also green. This is one possibility to upload some companion standards. Coming now to the possibility to generate your own address space out of one of these companion standards. I have here the possibility to generate local or mapped address spaces. I can add here, I press add. I have the possibility to create a new one from scratch, or I can also upload one which we have already created, maybe with a third-party tool like the Siemens or the Beyond tool, which are also able to generate address spaces. We are supporting the standard node set format from the foundation in this case. But I will create one from scratch. The naming, I will call it address space 1, but you can define your own name. You have to specify the namespace URI, a version, and a publication date. On the next page, you have the possibility now to select your address space, your companion standard on which your address space should be based. Now I thought, oh, maybe I don't want to use one of this one. I want to use our showcase PADIM. I have also here the possibility to upload it. I will choose here the PADIM and I upload it. Oops, I get a problem. This node set is missing. It shows you exactly if some required companion standards are needed for your chosen, I will say, companion standard. I have chosen this PADIM, and this PADIM requires also this IRDI node set file. And then I can also upload the IRDI. Then everything should be working. Upload. Yes, now then everything is working. So we have also some, I will say, not restriction. We are checking if everything is really uploaded what is needed to fulfill the requirements of a companion standard, because some companion standards has some sub-standards. In this case, PADIM is based on DI and IRDI. Then I press next, and on this page I can manage now my address space instances. By default, we see here what will be provided out of this companion standard, and I can now add here my own instances. I have here the option create instance. I will add here a folder, for example, folder 1 to generate my own structure. I can select here now as an object type, not base object type. I will generate a folder, press OK, create instance, and out of this, it's my instance created with a folder to have my own structure. Now I prefer to add here some additional information, like I will add here pH meter. It's a device which measures the pH. I will coordinate this way. I can create an instance, and now automatically my complete instance is created. Oh, I did a mistake. Sorry, I did a mistake. I created again. My mistake was I don't want to create a folder type. I want to create an object pH meter. It's a standardized object of the PADIM. I will say companion standard, which is more or less, which provides everything for a pH meter. When I press now OK, create instance, I have now all the information for a pH meter. This shows by default only the, I will say, mandatory references. So an object can have additional references, mandatory references, and optional references. By default, we create this object with the mandatory references, and I can now edit the references of this object. And here I have an easy way also to add here references. I can select everything, or I can select single ones. I will choose in this case everything, and now all the references are automatically created for this object. But we have in mind we are only creating the first level. If an additional object, in this case the device connection set, has also maybe some references, you must edit by hand. I can here add, for example, this general device condition. Then I have here this general device condition. And under this one, maybe I will add also some references. For me, I like this temperature value, for example, and then I have created here also the internal device temperature. In this case, I can create now multiple instances. I will create here a second instance. It's my pH meter 2, which is the same. To have here only show you 2. I will add here also my additional references. Close. Okay. Also, device condition set. General ones. Close. Why I will do it, I will show you later. And also now the temperature. Close. Okay. Now we have 2 pH meter. This is my address space now, which I want to provide through my UA server to my client. What is needed now to have also some values inside it? It's a mapping to the underlying sources. And this can be done here when checking here mapping. We get on the left side the address space from the aggregated sources. And in my case, I choose here from the data block 5 and room temperature sensor, and I can easily map it to this one. It was mapped. The data types are not 100% the same, but I can map it and we will do an automatic conversion. This was my first temperature sensor, and also I will choose the second one on other device, and yes, pH meter internal device temperature. And I can also do here this mapping. This is all what you have to do for providing this data from the underlying PLCs, what I have chosen here, in a self-created PADIM conform address space. I press now save. Now I have an address space 1, which I can now show via our server endpoints. I have here by default our OPC UA server endpoints. We are supporting multiple endpoints and also multiple users. But for our demo, I will use only the anonymous user. And what I have to do here is to select now the address space 1 and press save. That's all what you have to configure on the device. I copy paste now the URL of the endpoint to be able to connect. I open now a session, validate, okay. And here we can see now on our folder our 2 pH meter. And on this one, we have this device internal, what you can subscribe, for example. I will also subscribe to both. Right? So we have here our both values, temperature values. And if I put now my hand on my temperature sensor, one of this should be going up to do a live measurement. I hope it is working. No, I don't know why my temperature sensor is not correctly working, but normally you should see here the data moving. This is, I will say, the smallest point to provide the underlying information from this PLC in a standardized way. But how it helps now, I will say, the application. It helps the application in this context with this, I will say, PADIM companion specification device with this pH meter. On this internal device temperature, there are additional information provided to the application, the information about the unit. And when we see here the value of this unit, we see exactly the enhanced information because this is the display name, how it should be shown with this sign, degrees Celsius, and also how it will be described. So with a companion standard, you can provide additional information, add-on information to this information, this device information, in this case, our temperature sensor. This is a huge effort, I understand, if someone thought this, but if you do it once, close to your devices, all of the applications can directly work with this information, can read this information, and can provide this information via an HMI interface, can use it in an ERP system, and later on, they can also use it via AI information to analyze everything and so on. So from this point of view, it's really a complete package, which helps really the customers to streamline everything. This was my short live demo. Coming to a short summary. Yeah, as I already mentioned, our products, the secure integration service, the edge gate, and the connector are more or less the best product in class, I will say, for help you to manipulate OPC address spaces and to provide your data in a standardized and unified OPC address space. Helps you to integrate really brownfield devices. You can find some information about our products on the Softing Industrial homepage. And also, if you have later any questions, contact us also at info.automation@softing. So more or less, I will say thank you before I will answer the questions. I have already got 2 questions. One is from Kautori. Would you implement integration with a node set repo with OPC UA cloud library? to fetch nodes and files. At the moment, it's on our midterm roadmap to also support the information from the OPC UA cloud library. Second question from the same person is, can you apply simple calculations while mapping data from sources address space to target address spaces? It's not possible at the moment. This is our goal, to provide this functionality like a data manipulation or a pre-processing engine until the SBS fair this year, roughly in November this year. Can products be compliant to a companion specification? Yes, there may be in the future some products which are providing an address space, I will say, in a companion specification. But at the moment, there are really less products available on the market which are already providing, I will say, the data in a dedicated companion specification. But also have in mind, you want not have only the standard, I will say, companion specification, but in some cases you need for your own application, for your own processes, some additional add-ons. And in this case, maybe you must add additional information to this companion specification. And in this case, you need also our products maybe on top. But the first servers from some companies in the area, I know a machine builder which already provides something with Euromap. They are the first ones already on the market. Then I will say from my side, many thanks for your attention. Bye.